Hi, welcome back to Music Chemistry. This electron configuration of titanium. I said that right. TA lesson. Okay, well, first of all, it's element number 73 on the periodic table. So our atomic number, of course, is going to be 73. And our atomic mass number, according to the periodic table, is 181. Okay, so now we're ready to begin. If the atomic number is 73, that means it has 73 protons. For it to be electrically neutral, it would have to have 73 electrons. Now, what about the neutron count? Well, like in the previous videos, remember we use AMU minus the number of protons to get neutrons, right? Okay, so we go 181 minus 73 gives me a grand total of 108 neutrons. So we're going to put 108 right there. This is really easy, guys. Okay, a couple of quick rules to remember. Remember that S suborbits can only hold 2 electrons. P suborbit can hold 6 electrons. The D suborbit can hold up to 10 electrons. And the F suborbit can hold 14 electrons. We're going to use the off-ball principle, which states that we fill the lower shells first before we fill the upper shells, right? And we're going to use something called the diagonal rule. It looks like a gigantic slide. So we'll put an X right here at the top of the diagonal rule, and we're just going to slide along these orange-looking arrows until we run out of electrons, which happens to be 73 electrons. Okay, so let's go ahead and get started. Okay, so this gives me 1s2. Okay, then we come down to the 2s. That would give me 2. And then the 2p would give me 6. So far, so good, right? Then 3s2, then 3p6. Man, this is a lot of fun. Can you imagine doing this like at a football game or something? Wouldn't that be amazing? 4s2, 3d10, 4p6, 5s2, amazing, 4d10, 5p6, 6s2, 4f14, and finally 5d3. And if you add up all those electrons, you would get 73. Okay, so next one is orbital notation, and we use Hund's rule. Hund's rule says that we have to put an up arrow in a suborbit before we can start that down arrow in that particular suborbit. So like S, for example, would be up and down. 2s, up and down. Now watch this. We have 2px, 2py, 2pz. 1, 2, 3. They're all the up arrows in the suborbits. Now we can do the down arrow. See that? And that's Hund's rule. Beautifully spoken. Or shown. So here we go, keep on going with this. This is so much fun. It really is. What a joy. See how easy it is? You thought this was hard. It's not hard at all. It's really easy. I guess the only hard thing would be when you have to memorize all these little suborbit names like 4x, dx squared minus y squared, dxy, dyz, dxe, and dz squared. Now that would be kind of fun. And yes, my students do that. But they like it. At least that's what they tell me. They like memorizing these things. This one has 7. And then we start 7 down arrows. And last but not least, we got 3 to go. Well, isn't that just amazing? Okay, now we look on the periodic table. What's the nearest noble gas to titanium? It can't be radon because that's after it, so it has to be xenon. And now, like in our other videos we've been shooting lately, Xeon actually ends in 5p6, right? So that means you're able, when you use the noble gas notation, to cut out all of this and just put XE. Isn't that snarly? And then you just put the other ones in numeric order. Some people like to write it in the order that you see it there, but my finding is that this is the more correct way. I think it's just kind of been an argument among chemists for a long time, but this is the more correct way. Okay, now, Pauli exclusionary principle deals with quantum numbers. And although Tantalum looks like it's in the 6 period, we have to remember that the D block is n minus 1. So here we go 6 minus 1, which would be 5. So our n value is 5. Our angular momentum value, because it is in the D block, is going to be 2. It's the third element over, so we're going to have 0 for the magnetic number. And that last arrow is going up. So you can write 1/2 positive. Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Musin Chemistry.